consider the probability density function f of x equals x squared on 9, where x is between 0 and 3. So you can tell that's a continuous function, but it also says probability density function. So you don't get that mixed up with discrete, which was yesterday's work. So consider the probability density function f of x equals x squared on 9 for x is between 0 and 3. So just so you guys can picture this for yourselves, x squared on 9, it's just a parabola, looks like this, and it's saying it's starting from 0 to 3. Right, and that's pretty much the area that we've got in total. Draw a sketch of f of x within its defined domain. Tick, I just did that. All right, check that f of x is a valid probability density function. Tiana, how do I check if it's a valid probability density function?
You integrate it from 0 to 3, the function. X
Right.
on 9.
Otherwise, to you guys, I mean, this is just a normal function. Just anything. It's like I just said, it's just a parabola. But for it to be a probability function specifically, it needs to be the area under the curve of that function needs to equal to 1. If it doesn't, then it's not probability function. Equals, let's have a look. X cubed on 27, 3 and 0. Sub in 3, you get 27 on 27 minus 0 equals to 1. Therefore, valid PDF. Question? One of you have your mic on, just so you know. See. Find the probability that x is between 1 and 2. So pretty much saying find the area of this. Well, that's very easy, isn't it? Between 1, 2, x squared on 9 dx. Answer is x cubed on 27. 8 on 27 minus 1 on 27. 7 over 27. That's the answer to probability of x between 1 and 2. The inequality sign doesn't really matter if it's less than or equal to. Because they're continuous, that means they go to all the numbers between 1 and 2, which is there's infinite numbers. You don't need to think about the inequality sign so much. Any questions? You'll 100% get a question like this in your HSC, so be very prepared for that. Okay, yep. Good point. I didn't talk about the mode. That's the only thing I didn't speak about. Diagram shows a graph of a continuous probability density function. Which of the following is the mode? Maybe Tiana can remind us. Tiana, do you remember when where the mode occurs?
Isn't it at the highest range?
Is that highest range? Yeah, I guess that's a very fancy way of saying it. I would have just said maximum point, maximum turning point. Max stationary point, turning point, however you guys are thinking of it. So
is the mean, median, and mode or the maximum point?
0.8. No. To find mean, it's a little bit different.
Okay. I don't know. Well, okay.
You're talking about, oh yes, you're talking about this guy. Normal distribution.
Yeah.
Normal distribution. The mean, the mode, and the median are all equal to each other and they're all in the center. Because it's symmetric, whereas this is not symmetric, so it's not like that. That's for a normal distribution. Sounds good? So yeah. Mode, you guys, highest turning point. Okay. Then we got to CDFs. We just explained what a CDF is. Well, how to actually integrate it. Probability density function. Probability density is given by this. Find the value of b such that probability of x is less than or equal to b is equal to 5 over 8. All right, very good. Can anybody tell me how I'm going to write this up? it's saying f of x is equal to x plus 1 over 12 from 0 to 4 and 0 otherwise, which is usually the case. Find the value of b such that the probability of x is less than or equal to b with equal to 5 over 8. Anybody have any ideas? We are integrating. I can guide you.
Isn't it the integral from 0 to b of
Yeah.
the function
Yeah.
and then equal to 5 on 8?
Oh, too easy. Exactly right. So if it's less than or equal to b, that means it's from 0, starting from 0 to b of the function, it must equal to 5 on 8. Excellent work. And then let's just finish this off. Usually, you know, a constant 1 over 12, that's a 1 over 12. I usually take that on the outside and then just integrate the inside separately. So to me, I usually do it like this. If you guys do the same math, then excellent. Move it over. 1 over 12 x squared, sorry, sub in b squared on 2 plus b equals to 5 on 8. And then I think we know what we'll do from here. Just quadratic formula pretty much, right? Minus 5 on 8 equals 0. And well, if b was a negative number, you couldn't pick it because it starts from 0. So the only b value is b equals to 3. Nada, do you find these ones okay?
Yeah.
Again, easier than yesterday?
Yeah, those are easier.
These are easier. Yeah, year 12 usually is. I'm moving down, unless anyone's got any questions. Am I going too fast today? No. Okay. Pretty much be the same thing. I want to do a piecewise question because I know I haven't really done it in class. A probability density function is this. The median of this function satisfies the equation. Oh, very good. Okay, let's do that one. Firstly, let's talk about median, which we haven't exactly spoken about it here. Does anyone remember how to find median for in PDFs and CDFs? Even if it's wrong, just if you remember anything, how to find the median.
I don't know which one it's for. I think CDF is
It is
when it's
correct.
a half.
Equals to a half, did you say?
Yeah.
You're actually right. You're finding the CDF. Sorry, yeah, you're finding your CDF where it equals to a half. So pretty much you're doing this. Your CDF is from f of x equals from 0 all the way to x, 1 over 12, which we can keep outside, 8x minus x cubed dx, that needs to equal to a half. And then the x value you would find you the median, but in this case it just says which one of these are the equations that would find you the median. So let's just continue. 8x squared on 2 minus x to the 4 on 4. Usually they try to use a different letter, you know, here or here. So I could have used m. I guess I'm going to use m just for the sake of keeping it with the same letters that they've chosen. Or you could have kept it as x. It doesn't actually matter. Okay, sub in m. I'm going to times by 12 just because it'll make it look a little bit better. 8 over 2 is 4 as well. So it becomes 4m squared minus m to the 4 on 4. Half times 12 is 6. I can see my answer is not there, so times it by 4 as well. I would get 16 m squared minus m to the 4 equals 24. Do I have it? Positive m to the 4 minus 16 plus 24. I think the answer is E. Positive m to the 4 minus 16 and then plus 24. Good job, Aya. You happy with that?
Yeah.
And by the way, these are all, you know, not HSC because this is a new syllabus. These are all Victorian HSC exam questions. So pretty much these are the style of questions you guys will get. Good stuff. Function is a probability density for a continuous. Show that k equals to pi over 2, which is fine. Find the probability of x less than or equal to a quarter, conditional such that x is less than or equal to a half. Conditional to quarter, conditional, and over probability of x less than or equal to a half. That one's fine. And it's probability of x is less than a quarter, and we have x less than or equal to a half, which is just probability of x is less than or equal to a quarter. Interesting. Interesting. All right, we're going to try that one and see. Let's do A first anyways. A. The function is a PDF for the continuous random variable. Show that k equals to pi over 2. Again, what do we know? We know that the integral of 0 to 1, from 0 to 1, of k sine pi x dx needs to equal to 1. The probability of the whole thing needs to equal to 1. So integrate sine. To integrate sine is negative cos, if I'm not wrong. Negative cos divided by the derivative of the inside, which is a pi. Used to have k on the outside. 1 and 0 equals to 1. Then we're going to put 1 into our calculator. This way you've got to be careful. If you're going to put cos pi as pi, your calculator needs to be in radian mode. If you're not, if you're going to do cos 180, then it has to be in degree mode. So be very careful with that. When you're cosing, sining, or tanning a radian, you've got to make sure you're in radian mode in the first place. All right, I'm just trying to grab my calculator out myself. Okay. Cos 180 is negative 1. Cos 180 is negative 1, so that gives me 1 on pi, minus cos 0 is 1. 1 over the negative becomes a plus 1 on pi, equals to 1. 1 on pi plus 1 on pi becomes 2 on pi, equals to 1. And then multiply by pi, divide by 2, pi over 2. Just double check my working out here for yourself, making sure that you would have written the same thing, please. Okay. Any questions there? All right, let's try B. So that's a conditional question. Probability of A conditional to B is probability of A and B on probability of B. So what you probably have seeing me do was I was writing probability of x less than or equal to a quarter, conditional to x being less than or equal to half, is the probability of x being less than or equal to a quarter and x being less than or equal to half, over probability of x being less than or equal to half. Now that the bottom part's okay, we could do that. My logic for the top part, which I can check if it's right or wrong, but I mean, we have the answer. My logic anyways is if a number is to be less than or equal to a quarter and less than or equal to half, that means that number has to be less than or equal to a quarter. So that's my logic right now. Let's see if it makes sense, and then I'll explain it a little bit further if it's right. If it's wrong, I don't know if I've got much more other than that. So let's see. Less than or equal to a quarter. So less than or equal to a quarter would be the integral, k 0 to a quarter sine pi x over, again, k integral from 0 to a half sine pi x dx. I know we've already worked out k, but as you can see, k's will just cancel out. The integral of sine, I'm going to rub this bit out now. The integral of sine we said was negative cos pi x on pi from a quarter to 0, and then same thing, but a half and 0. All right. So that becomes, next line, equals, all right, if I sub in a quarter, negative cos 45. Negative cos 45 is negative root 2 on 2 pi minus subbing 0 into that, it gave me 1, so it becomes plus 1 on pi over subbing half, negative cos 90 is 0 minus subbing 0 is 1 on pi. That becomes negative root 2 plus 2 on 2 pi times 1 on times pi. Pi and pi cancels out. Was the answer negative root 2 plus 2 on 2? Good. Sam still got it. All right. I doubt anything of that made sense, but did it make sense to anybody? And you can see I'm trying to put myself in your shoe and think about it the way you hopefully can think about it in your exam. All right. Tiana, let's start from the top. You're going to confirm for us if everything's good. You're going to ask us any questions you've got. Ready? Tiana. Emily, then?
Okay.
Yeah. All right, ready?
Yeah.
All right, so we know you agree with this formula?
Yeah.
All right. Then I wrote this. Do you agree with what I've written?
Yeah.
Probability, okay, that's pretty much using this formula. Now, the bottom is fine. The top, it says probability of x being less than or equal to a quarter, and x has to be less than or equal to a half. Well, what does that mean to you? If something has to be less than or equal to a quarter and less than or equal to a half, then it definitely needs to be less than or equal to?
Just a quarter.
Yeah, just a quarter.
Yeah.
Do you agree with that logic?
Yeah.
Cool. Then, I mean, if that was a question in itself, you would have just done it from 0 to a quarter of sine pi x dx, right?
Mm-hmm.
And then, so I've just done the exact same thing. K 0 to a quarter sine pi x dx, and then same thing here. K 0 1 over 2 sine pi x dx. So you happy with all that?
Yeah, that makes sense.
Yeah. Now, what I think everybody should do, because really that part there, if you knew this, I mean, if you could get this bit out from here to this line, then this line wouldn't have been a problem. Usually this this line is also not a problem. Regardless if you cross that K or not, it wouldn't be a problem. The problem actually is this line, subbing it in. So what I want everybody to do is, however you want to write this line in orange, write it. You want to write it as a fraction like this, you want to write it as a division sign. I want to make sure that you guys can get to the final answer yourselves. In however you have to do it. You don't have to do it, in 1 or 2 steps like me. I do it pretty fast, but just start with the orange line and really try to see if you can get to the answer itself. And then Emily, confirm to me with me once you've done that, I guess.
I got it.
You got it?
Yeah, I did it the way when you times it, because I don't like seeing fractions on top of each
Yeah,
other.
perfect. That's it. That's perfect. Everybody else? Confirm you're good as well. Tiana, you happy with it?
Yeah.
All right, done. That was it was a different question because they brought in something that we've learned in year 11 and brought it into year 12. All right, let's have a look at some of the piecewise. That's what I was looking for. Yeah, not the one I wanted though. Do another one. Yeah, we'll do that one in a second. Uniform, that's easy. Okay, fine. These Western Australia questions are funny. All right. Let's do, did I miss one? I guess we'll look at this. The problem is, I was looking for a better question. What was I looking for? I was looking for, less than or equal to 1. Or even 1. Okay. Let's do this. A probability density function is defined piecewise by this. Find the value of the constant k. Hence, write the equation of f of x and sketch it. Okay. So, of course, to find the value of constant a, it's just going to be, constant k, it's just going to be the integral of k 4 plus x from -4 to 0 plus k integral 4 minus x from 0 to 4 must equal to 1. That makes sense, doesn't it? Two different functions split up. That just means each one, and then add them together, so separately and then add them together, will need to still equal to 1. So the whole function is defined from -4 all the way to +4. Okay, and then of course, k 4x plus x squared on 2 plus k 4x minus x squared on 2 equals to 1. And then k sub in 0 doesn't do nothing. Minus 16 plus -4 is 16. 16 on 2 is 8. I'm sure we get the rest. 16 minus 8, and then the 0 is nothing, equals to 1. -16 plus 8 is -8. That becomes 8k plus 8k equals to 1. K equals to 1/16. All right. Any questions there? Nope. Easy. All right. Part B. What is probably the probability of 0? X is between 0 and 2. Anyone want to help me out with what they would write for B? We know K is now 1/16. So what would you write for this one? Integral.
Integral of 1/16 of 4 plus x, but you take the 1/16 out. Yeah, like what you just did.
You're very close. Think about it again.
From 0 to 2.
Yeah, 0 to 2 is right. And what's the function?
Minus x.
Yeah. 4 minus x. Why?
Because it's from 0 to 4.
Yeah, that's where your domain is, right? So 0 to 2, it's inside that domain, not that domain. Careful. And then you guys will just do it. Why is the median 0? I think the median will be 0 because I can see it's pretty much symmetric. So when you do your CDF, it'll be symmetric exactly at 0. What is the mode? The mode would occur at your maximum point, which would be, by just looking at it, it's annoying. I would rather just sketch it. So what I would have done, I probably would have done D before even answering C, because it just says sketch the whole CDF. Oh, so it says sketch the CDF, not sketch the PDF. That's right, we will sketch the PDF. So to sketch the PDF, essentially that's just, y equals to 1/16, 4 plus x. So when x is 0, y equals to 4/16, y equals to a quarter. When y is 0, x equals to -4. There's that one. Of course, it's not for the whole domain. It's only from -4 to 0. So just keep that in mind. But I'm just trying to draw both graphs. Next one, y equals 1/16, 4 minus x. When x is 0, you're still going to get a quarter. And then when y is 0, you get x equals to +4. And I think you guys can see what I meant by it's symmetric. So what happens is pretty much the area of this bit, because it cancels out with the area of this bit, your median is literally just going to be occurring at the center, which is at 0. What is the mode? Actually, your mode is going to be a quarter now. Now that I've drawn this up, I can see the maximum point on the top. Sorry, your mode is not a quarter. It occurs at the maximum point. The maximum is at a quarter where it occurs at x equals 0. So your mode is also 0. Same reasoning, symmetric, but that's also 0. So the maximum point is there. Your answer is where it occurs. So you're finding whenever you do y dash equals 0, let's say, you're finding x technically, right? You're not finding y. So you find out where it occurs. You sub in to find your y value. So, and then find the CDF and the CDF for the other one. Well, that's easy. I'm not going to really do that again. I think we already get it. 0 to x, 1 over 16, 4 plus x dx, and then do the same thing again for the other domain. And then sketch it. Well, it looks like it'll become a, when you integrate this, that looks like it's going to become a parabola. So you're just going to sketch very likely a one happy parabola, one sad parabola. So it'll probably look like this. And then, again, it'll be symmetric about each other. Everyone okay with that? Can someone just confirm they're okay for me to move on?
I think we're okay to move on.
Done. Let's do this from the actual sample HSC. Looks like it's the same. Yep. I guess the only thing is, if you guys remember when I said your CDF, even though I make it look very easy, you do have to write it like this. So, sorry, I missed the domain part. You do have to write it like this. So the way it works is that is the part you've integrated from 1 to x. So when you're going to do your CDF, you're going to integrate from 1 to x of k 16 minus x squared. And that's fine. You'll end up with all of that. But to write your CDF properly, you've got to write it for the domain. For that domain, it should be that. Anything after 4 is always equal to 1. Anything before your lowest domain, so 1, it's going to be 0. So 0, then your CDF, then 1. That's the proper way of writing it. So just be aware of that. And then if we read the question, a bid made at an auction for a real estate property in millions of dollars can be modeled by the random variable. Find the probability that a bid of more than $3 million will be made. So find the probability that X is bigger than 3 million. The idea is you can either integrate it from 3 to 4 of the whole thing, right? From 3 to 4. Or because you've already got your CDF function, but don't forget your CDF function starts from 1. Starts from 1. So when you're drawing it, let's just say whatever, it doesn't really matter what it is. It starts from 1 to x. Let's just say that was 4. X can be any value. Since that's your CDF, which has already been integrated, if you're trying to find it from 3 to 4, so you want to find this answer, what you could have done to make it a bit faster, you would just sub in 3 into here, but subbing in 3 finds you this, and then you take it away from one whole, 100%. So what you could do, the fastest way to do C, it was either this, which is fine, or it would have been 1 minus sub x equals 3 into CDF. Now, whichever one you're comfortable with. Most students have been more comfortable with the green one. but some who've understood it are even more comfortable with the CDF. So it's really up to you. If it doesn't say which one to pick, which it doesn't, it's really up to you. Does this bit need to be explained a bit more? We didn't do much work on CDF parts like that. Does anyone want more explanation of this, or are they okay? Maybe we just stick into the green one for now. Okay. All right, moving on. Like I said, uniform's not an issue. They're even easier. Okay, that just says find the area. It doesn't actually say it has to be a probability. Take them as x approaches infinity and show that. Yeah, we'll do that one. That one looks a bit different. And that's it. All right, let's try that one. Find the area under the curve. Okay, it doesn't say anything else. It just says find the area. So you just go and integrate it from 1 to a of 1 on x squared. So then that becomes 1a x to the negative 2 x to the negative 1 over negative 1 a1 a to the negative 1 over negative 1 minus 1 to the negative 1 over negative 1. All right, that becomes negative 1 over a plus 1. That's the area. So 1 minus 1 over a. Take the limit as a approaches infinity and show that y equals 1 on x squared is a probability distribution function. Okay, so for part B, it says take a approaches infinity. What happens to 1 over a as a approaches infinity? What happens to the 1 over a? So what's 1 over infinity? Yeah, that approaches 0. So what happens here? 1 minus 1 over a will approach 1 minus 0, which approaches obviously 1 minus 0, which approaches 1. Therefore, y equals 1 on x squared is a PDF. Because if it equals to 1, which it needs to, it's a probability distribution function. And then last one just says find the corresponding CDF. To find the CDF, we know it by now, but let's just do it one more time. What's your lowest limit? 1 to x of x to the negative 2 dx. We've just integrated that, right? So we kind of technically already know it's going to end up to become this. Just imagine instead of a, it was x. You've technically already done it. So that is the CDF. Just so you know that, unless you wanted to do it all again. But then how did I say we want to write it? So we want to write it like this. F of x equals 0 for x less than 1. It is 1 minus 1 over x for between 1 and x and a. And then it is 1 for anything bigger than a. Perfect. Very good with that. Done.